Dear all, in this video, I'll be discussing about resistive transducers. So in order to get the previous video, please click the I button on the top of the particular video. Then you will be getting the entire playlist of sensors and transducer. Let us continue the discussion on resistive transducers. First and the foremost, let us understand what do you mean by a resistive transducer, or you can call resistance transducer. The transducer whose resistance varies because of the environmental effect such as temperature, pressure, etc. And such type of transducers are known as resistive transducer, or you can call resistance transducer. Okay, temperature, pressure, etc. are called non-mechanical quantities. Then you will be getting the output in terms of resistance, that is called electrical quantity. So non-electrical quantity that will be converted into electrical quantity. Okay, so that is regarding resistive transducer, or you can call resistance transducer. The resistive transducer is used for measure temperature, pressure, displacement, vibration, etc. So such kind of mechanical quantities can be easily measured by using the principle of resistance. Let us understand the basic principle of resistive transducer. Change in value of resistance with change in the conductor can be used for the measurement of translational and rotary displacement. Translational motion is in the sense linear motion. So you can able to measure both linear motion and rotational motion, circular motion. You can point out one of the example of resistance based transducer, that is called a strain gauge. So let us understand what is happening in case of strain gauge. Strain gauge is one of the example of resistance transducer which measure displacement, force, pressure, etc. And you can able to say that there are two types of resistive transducer. First one is linear motion potentiometer and another one is rotary motion potentiometer. In the upcoming slide, we are going to discuss about the main classification of resistance transducer. So before studying about resistive transducer, you should understand the important formula. We can say that this is the working principle of resistance transducer. You know that resistance of the conductor or a material that is given by rho L divided by A, where rho is known as specific resistance, or you can call resistivity. So it is expressed in terms of ohm meter. And also length is the total L. L stand for length of the conductor or a material. Okay, it is expressed in terms of meter, SI unit. Then you can talk about A, that is regarding area of cross section of the material. That is equal to uh, A means in terms of meter square. You will be expressing in terms of meter square. So that we can say that the resistance will be directly depending on L. And also we can say that resistance is inversely proportional to area of cross section. So this is the relation. These two parameters are directly influencing on the performance and the working principle of resistance transducer. Okay. Now let us explain what are the differences between a linear motion potentiometer and a rotary motion potentiometer. So moving on to the discussion, you can able to observe linear motion potentiometer and a rotary motion potentiometer. So let us explain about linear motion potentiometer. Actually, our intention is to measure non-electrical quantities. It may be displacement or distance, or you can say velocity, whatever it may be. So the moving object that will be directly connected to a slider. You can clearly observe. This is your moving object that will be directly connected to slider. Here we are going to measure linear displacement or linear velocity, whatever it can be. Now what you can do is you have to consider the resistive element. This is your resistive element. I am marking with the help of a pointer. This is your resistive element. You are going to provide the supply over here. This is your supply. Okay. L is the length of resistive material. A is the area of cross section of that particular resistive material. Now what you can do is the slider that will be directly connected to the moving object. So with respect to the linear motion of the slider, okay, whenever the linear motion is taking place, the position of the slider is also getting changed. With respect to changes in position of slider, you will be getting the output voltage. So it will act as a voltage divider. Okay, so that anyway we are going to provide a constant input voltage at the resistive element, and there is a slider. That slider will be directly connected to mechanical uh, body. Okay, it will be under continuous linear motion. So we can able to measure, it may be displacement or distance, whatever it can be, that is in terms of the output voltage. Okay, so the variation in the resistance leads changes in the output voltage. So this is exactly happening in case of linear motion potentiometer. On the opposite side, you can able to measure the Circular motion, in the sense, it is mainly used for measuring rotary motion potentiometer. Circular motion can be measured. So you can able to see the slider. Okay, it is very clear that a slider, it is arranged in a circular shape, and you are going to provide, okay, not only not slider, resistive element. First of all, I would like to tell about resistive element. So where is the resistive element? This is your resistive element. You can able to observe the resistive element. So resistive element is arranged in the circular fashion. Even slider is also arranged in a such a way that it can move in a circular fashion. Okay, the slider will be provided a constant input voltage. We are going to provide a suitable supply for the particular resistive element. Okay, resistive element is placed over the, we are going to provide the constant input voltage, say 24 volt or 48 volt, whatever it can be. Yeah, now we can look at the position of the slider. See, slider is locating over there. So this is your mid position of the slider. Okay. Now you can observe that the moving object that will be directly connected to the slider. Okay, slider will perform the circular motion. So the moving object is directly connected to the slider. Whenever the moving object is performing the motion, slider is also going to rotate. So with respect to the rotation of slider, you will be getting the output voltage. So the thing is, whenever slider is getting changed, the input voltage, the voltage which you applied, that is also getting varied. Okay. As the slider changes, resistance is getting varied. That resistance will be directly proportional to the change in voltage. So you can able to measure the changes in a slider in terms of voltage. That means as the moving body perform different motions, it may be rotational motion, it will be rotational motion. Okay. As the moving body performs the circular motion, you are able to get the output voltage. With respect to the motion, you are able to get the output voltage. This can be measured over here. Okay, because the resistance element, the value of resistive element will be getting varied. Okay. Normally, we are going to use wire bound type resistor. Okay. The scale will be 0 to 60 degree, normally 0 to 60 degree. So let me talk about more details about this kind of transducer. Okay. I'll be putting lot of information regarding this kind of transducer in the next slide. You can go through the next slide. See, a linear motion potentiometer or rotary motion potentiometer converts motion of rotating shaft into changes in resistance. Whenever changes in resistance is occurred, the output voltage is also getting varied. That point also you have to remember. In case of rotary type resistive transducer, the rotary device varies from 0 to 10 degree to 60 degree. It may be from 0 itself in the form of 10 at the range of 10, 0, 10, 20, 30 likewise. And also the changes in the resistance in the potentiometer is then an indication of the amount of motion and the direction of movement. That is very clear. You have to underline this particular point. That is indicated by whether the resistance is increasing or decreasing. That also can be obtained from the resistive transducer. What are the quantities can be measured? Pressure, force, acceleration, then linear velocity, angular velocity, those parameter can be measured. Okay, even you can able to measure the liquid level also. What are the power ratings of the potentiometer? It is available in the rating of 5 watts, and the temperature, it can be varied up to 21 degrees Celsius, and the diameter will be around 50 millimeter, and the value of resistance that is varied from 10 ohm to 10 kilo ohm at the steps of 100 ohm. Suppose it's available like 100 ohm, 200 ohm, likewise it's available. Okay. What are the materials? I already explained what are the materials which can be used for making this kind of resistive transducer. Normally, we are employing wire wound potentiometer. Even you can go for non-wire wound potentiometer also. Okay, these are the basic peculiarities of resistive transducer. Okay. Now let us list out a few advantages of resistive transducer, or you can call resistance transducer. So normally wide range of output, you will be getting high output, and it is cheap and available in different size and different shape also. Simple to operate. Okay. And principle also quite simple. It obeys the equation mainly. R is equal to rho L divided by A. Resistive transducer gives the fast response compared to other type of transducer, high electrical efficiency, and rugged construction. Construction will be robust. Okay, these are the main advantages. If I talk about the disadvantages, limited life due to wear and tear, because for in case of linear type resistive transducer, the slider will move up and down. So with respect to the movement, definitely there will be wear and tear that will be happening for the resistive element. That is why we are going to say, we are saying that lifespan of the particular equipment is less, and the output is too noisy. We won't get the smooth output. That is another drawback of this type of resistive transducer. Okay. However, it is quite common. What are the major errors encountered in this kind of transducer? Normally, scale errors, because that scale is non-uniform. So, moreover, the accuracy is another issue. Then dynamic errors. What do you mean by dynamic errors? Dynamic error is the difference of the true value of the quantity changing with respect to time and the value indicated by the instrument if no static error is assured. Okay. So there is a reference value and actual value. That difference is referred as dynamic error. That is another issue regarding the resistive type transducer. And the noise and drift errors. So it is mainly occurring due to change in gradual variation of the output. Okay, these drift errors are most common in case of resistance transducer. That is why some cases we are not able to use this kind of resistive transducer where you require more accuracy. Okay, such cases you can go for other type of transducer. Let us discuss what are the major applications of resistance transducer. Majorly, we are going to use potentiometer, strain gauges, resistance thermometer, then thermistors, and also RTD. Okay, resistance temperature detector. These are the various applications of resistance transducer. I have referred the following textbooks. Now let us conclude the session. First of all, I have discussed about what do you mean by resistance transducer. Normally, the physical phenomenon such as temperature, then variation pressure, that will be converted in terms of resistance and you can able to measure the output voltage. That is exactly happening in case of resistance transducer. Non-electrical quantities such as displacement, pressure, etc. will be measured in terms of resistance. And you have to follow the main equation. R is equal to rho L by A. Okay, so based on the equation, it is going to operate. There are two classification, linear motion potentiometer and rotary motion potentiometer. So I have explained the working, how does it operate. Okay, so first one is mainly used for the translational motion, linear motion. You can go for linear velocity, linear displacement likewise. If I want to go for circular motion, go ahead with the rotary motion potentiometer. So afterwards I have explained the different type of transducer and I have given the specification, details, etc. Afterwards, I have discussed about pros and cons of resistance transducer. Afterwards, I could list out a few errors which are occurring in case of resistance transducer. And finally, I have listed out the applications of resistance transducer. In the next session, what I am going to discuss is the one of the major applications such as thermistor, applications of resistive transducer such as thermistor, and afterwards I will be discussing about RTD, resistance temperature detector. These are my plan of action in the upcoming session. If you are having any queries related to this resistance transducer, please do let me know. You can put up your comments in your comment box. Finally, thank you very much for watching this video.